Hello everyone, welcome to the video. In this video, we're going to dive into the fundamentals of PCR polymer chain reaction. I will walk you through how PCR works, how to manually set up a reaction, and how to use a master mix to simplify the process. We'll cover all the essential components required, their roles, and how much of each you will need. Even if you're already familiar with PCR, it's always good to revisit the core concepts. As you know, PCR is a technique used to amplify a specific segment of DNA, allowing us to analyze gene in greater detail. So let's break it all down step by step, and I'll try to make sure you understand everything clearly. Here, what you can see the manual reaction setup and the master mix setup, and their components and volume you need. So first, I will go with manual reaction setup. So all here you can see I set manual PCR reaction for 10 microliter. You can also set the reaction for 25 or 50 microliter. If you understand how I set this 10 microliter reaction, you can easily set up a reaction for 25 or 50. No worries. You can see all the components you need to do a manual PCR. See the stock concentration here for the DNTP, primers, magnesium chloride, and the tech polymers. You can also check the final concentration, working concentration basically. Our 5x Kotek reaction buffer already contains 1.5 millimolar of magnesium chloride. Just remember it, I will discuss it later. So, how will you make working concentration from stock? And how do you set volume for 10 microliter reaction? And also for 25 and 50 microliter reaction, I will discuss one by one. So, let's dive into it. We all are familiar with this formula, right? C1P1 is equal to C2P2. We calculate all components for a 10 microliter PCR reaction using this formula. So let's start. First, 5x coated reaction buffer. The reaction buffer is essential for creating the optimal chemical environment for tag DNA polymerase or any polymerase. It maintains pH, which is optimal for enzyme activity. It also prevents enzyme denaturation or reduce efficiency. This is how you will calculate 5x Kotek reaction buffer. Here is the 5x, which is our stock concentration. Here is our desired concentration, and here is the volume you want to make. If you want to make 25 or 50 microliter of reaction, just put the value of 25 or 50 here. And here is the V1, which is basically the volume we want to calculate. Okay. DNTP provide nucleotides for DNA synthesis. In PCR, DNTPs are incorporated into the growing DNA strand by DNA polymerase complementary to the template strand. So if you already have DNTP mix with prepared concentration, you do not need to make it. But if you do not have DNTP mix but have DATP, TCTP, TTTP, and DDTP separately, this is how you can make it following the similar formula. You can see that there are C1 100 millimolar stock. Basically, the DATP, DTTP remains in 100 millimolar stock, and you want to make it 2.5 millimolar, your desired concentration. So this is how you can make the following using the following formula. Okay, just you need 25 microliter of each nucleotides, and just add 900 microliter of nucleus-free water to make the desired concentration 2.5 millimolar. Now I already made the DNTP mix. Now how much DNTP I require for 10 microliter reaction? So as I already mentioned earlier, and is 0.2 millimolar as standard for 10 microliter reaction. So just calculate C1 V1 is equal to C2 V2, and after that you can know that I need 0.8 milliliter of 10 millimolar total data from total data mix. Now, let's talk about the primers. Primers are essential for amplifying a specific gene during PCR. If you are looking to design a gene-specific primer, I have already made a detailed video on that. Just check the link in the description. Now, if you have already ordered your primers, you probably noticed that the manufacturer provides instruction on how to prepare the stock solution, usually at a concentration of 100 micromolar. For those who are new to this, let me show you an example. I ordered my primer from IDT, and they clearly mentioned how much NFW nucleus-free water to add to achieve a 100 micromolar of concentration. Here they say that I have to add 260 microliter of nucleus-free water to make my final concentration of 100 micromolar. If you order the primer, they will give you information like this. Now let's talk about the primer dilution. Once you have your stock primer, usually at 100 micromolar, you will need to prepare a working concentration from it. I typically make a 2.5 micromolar working solution for conventional PCR, but you can adjust this depending on your experimental needs. For example, if you are seeing primer dimer formation, you might need to lower the primer concentration. On the other hand, if you are not getting any PCR bands, you may need to increase it slightly. So it's flexible. You can modify your working concentration accordingly. Personally, I find 2.5 micromolar works well for standard PCR. For qPCR, though a higher concentration like 10 micromolar is often required. Let's say I want to prepare 100 microliter of my 2.5 micromolar working solution. Let's calculate how much stock primer and NFW we will need. So here is my stock concentration and the desired final concentration that I want to make. Okay. So here the volume of working concentration, working primer concentration that I will require. So here is the calculation, 2.5 microliter. To make 100 microliter of 2.5 micromolar primer, I need to add 2.5 microliter from 100 micromolar primer stock, and I need to add 97.5 microliter of nucleus-free water, which makes my primer working solution of 2.5 micromolar. Then use 1 microliter from 2.5 micromolar primer solution for a 10 microliter reaction. Magnesium chloride is an essential cofactor for Taq DNA polymerase or any other thermostable polymerases. It helps the enzyme catalyze the incorporation of DNTP into the growing DNA strand. So how you calculate this? As I mentioned earlier, I have 1.5 millimolar of magnesium chloride in my reaction buffer. So, but I want to make the final concentration of magnesium chloride into 2.5 millimolar. So extra magnesium chloride that I need is 1 millimolar. So for 1 millimolar, I have to take 0.4 microliter of magnesium chloride from the 25 millimolar of my stock. Okay. So this is how you can increase the concentration of magnesium chloride in your reaction mixture. Now finally, coated DNA polymerase. There are different type of DNA polymerase such as high fidelity fusion polymerase, PFA polymerase, Q5 DNA polymerase. But most of the lab use coated DNA polymerase because it's cost effective. There are 5 unit Godek polymerase in per microliter of sample, per microliter of solution. So for standard 10 microliter of reaction, you need final 0.5 unit of Taq polymerase. So desired units and the stock concentration. So basically you need 0.1 microliter of Godek DNA polymerase for 10 microliter reaction, but you cannot pipette up 0.1 microliter. So maximum lab has a pipette that can highestly take 0.5 microliter properly. So what you need, take 0.5 microliter of 5 unit per microliter stock, add 4.5 microliter of NFW nucleus-free water, which make total volume 5 microliter. So you can just make a dilution. I here just make a dilution. You can see here. So the 5 microliter you have made, every microliter has 0.5 unit concentration. Okay, so if you take the 0.5 microliter from the stock concentration of 5 unit per microliter, you basically taking 2.5 unit. Okay, so this is how we can calculate this. Now you can use 1 microliter of DNA polymerase for PCR reaction. But remember one thing, you need to dilute the Taq polymerase only when you are working with. Okay, because it's heat sensitive, Taq DNA polymerase loses efficiency if it's pre-diluted. So dilute when you are working with Taq DNA polymerase. And here is a template DNA. Template DNA will be based on about your DNA extraction. You extract the DNA that has concentration of 100 nanogram. So dilute it because PCR need only small amount of DNA. 20 nanogram is more than enough in per microliter. Isolated the DNA and it has 100 nanogram of concentration. Dilute it 10 times to and use 1.5 to 2 microliter. But if you isolate the DNA that has lower concentration like 10 nanogram, so you can use 2 microliter of template DNA. That will be enough. Top up the remaining volume with nucleus-free water. Now, master mix. So, master mix is already pre-optimized concentration of tag polymerase buffer, TNTP, magnesium chloride. You need to calculate anything for if you are using the master mix. All you have to need is master mix 5 microliter, forward reverse primer 1 to 1 microliter, template TN1, and nucleus water 2 microliter, and final control polymerase 10 microliter. So with the master mix, you already have pre-concentrated tag polymerase buffer, DNTP, and magnesium chloride. All the concentration is pre-optimized in master mix. So it is very easy for pipetting, or there is no hassle like calculation and all the things. PCR using the master mix is very easy thing. But if you want to understand the PCR, you have to go with the manual process. Here I already give you a reaction parameter if you want to make 25 microliter reaction. For 25 microliter reaction, there is a standard 0.625 unit of tag DNA polymerase. All of the remaining will be same. And here it is for master mix for making 25 microliter reaction. It is the Thermocycler program. Just handling temperature will be varied. Basically, it is plus minus 3 degrees Celsius from the handling temperature. So fix this handling temperature according to your research and give it a thermocycler program. Thank you for watching my video. If you have any confusion in anywhere in my video, just comment it. Thank you very much.